In this video, we are going to see about what is unpaired t-test or independent t-test in hypothesis testing. What is unpaired t-test? An unpaired t-test, also known as an independent t-test, is a statistical procedure that compares the averages, means of two independent or unrelated groups to determine if there is a significant difference between the two. The unpaired t-test is used to make a statement about the population based on two independent samples. To make this statement, the mean value of the two samples is compared. If the difference in means is large enough, it is assumed that the two groups differ. Formula for unpaired t-test. The unpaired t-test is divided into two types. 1. Equal variance t-test. 2. Unequal variance t-test. 1. Classical two independent samples t-test, student t-test, or equal variance t-test. If the variance of the two groups are equivalent, homoscedasticity, the t-test value, comparing the two samples, A and B, can be calculated as follows. 2. Welch t-statistic, or unequal variance t-test. If the variances of the two groups being compared are different, heteroscedasticity, it's possible to use the Welch t-test, which is an adaptation of the student t-test. The Welch t-statistic is calculated as follows. What are the hypotheses of an unpaired t-test? The hypotheses of an unpaired t-test are: the null hypothesis, H0, states that there is no significant difference between the means of the two groups. The alternative hypothesis, H1, states that there is a significant difference between the two population means, and that this difference is unlikely to be caused by sampling error or chance. Assumptions of unpaired t-test. 1. The two groups, or samples, must be independent. As the name of this t-test suggests, the samples must be independent. This means that a value in one sample must not influence a value in the other sample. Correct: measuring the weight of people who have been on a diet and people who have not been on a diet. Wrong: measuring the weight of a person before and after a certain diet. 2. The variables must be metric scaled. For the t-test for independent samples, the mean value of the sample must be calculated. This is only meaningful if the variable is metric scaled. Correct: the weight of a person, in kilogram. Wrong: the educational level of a person. 3. The variables must be normally distributed. The t-test for independent samples gives the most accurate results when the data from each group are normally distributed. However, there are exceptions in special cases. Correct: the weight, age or height of a person. Wrong: the number after throwing a die. 4. The variance within the groups should be similar. Since the variance is needed to calculate the t-value, the variance within each group should be similar. Correct: weight, age or height of a person. Wrong: the stock market crisis in normal times and in a recession. Why do you need the unpaired t-test? Say you want to test if there is a difference between two groups in the population, for example, if there is a difference in salary between men and women. Of course, it is not possible to ask all men and women for their salary, so we take a sample. We create a survey and send it randomly to people. In order to be able to make a statement about the population based on this sample, we need the independent t-test. What are independent samples? Independent samples are samples that are selected randomly so that its observations do not depend on the values other observations. Many statistical analyses are based on the assumption that samples are independent. Example of independent sample. For example, suppose quality inspectors want to compare two laboratories to determine whether their blood tests give similar results. They send blood samples, drawn from the same 10 children to both labs for analysis. Because both labs tested blood specimens, from the same 10 children, the test results are not independent. To compare the average blood test results, from the two labs, the inspectors would need to do a paired T-test, which is based on the assumption that samples are dependent. To obtain independent samples, the inspectors would need to randomly select and test 10 children using Lab A, and then randomly select and test a different group of 10 different children using Lab B. Then they could compare the average blood test results from the two labs using a two-sample T-test, which is based on the assumption that samples are independent. Examples of unpaired T-test. Example 1. For example, suppose that we have measured the weight of 100 individuals, 50 women, Group A, and 50 men, Group B. We want to know if the mean weight of women, MA, is significantly different from that of men, MB. Example 2. Research during which there are two independent groups, such as women and men, that examines whether the average bone density is significantly different between the two groups. Example 3. For a pharmaceutical company, you want to see if a drug XY helps you lose weight or not. This is done by giving 20 people the medicine and 20 people a placebo. Example 4. You want to find out if there is a difference between the health of people with and without university degrees. Example 5. For a screw factory, you want to find out if two production lines produce screws of the same weight. To test this, you weigh 50 screws from one machine and 50 screws from the other machine, and compare them. Research question. Is there a significant difference between the examination results in the summer and winter semester? Null hypothesis H0. There is no difference between the two samples. There is no difference between the statistics exam results in the summer semester and in the winter semester. Alternative hypothesis H1. There is a difference between the two samples. There is a difference between the statistics exam results in the summer semester and in the winter semester. After copying the above sample data into the hypothesis test calculator on Data tab, you can calculate the t-test for independent samples. The results for the t-test example look like this. How to interpret a t-test for independent samples. To make a statement about whether your hypothesis is significant or not, one of the following two values is used. 1. P-value, two-tailed. 2. Lower and upper confidence interval of the difference. In this t-test example, the p-value, two-tailed, is 0.312 or 31%. This means that the probability that you draw a sample where both groups differ more than the groups in the example is 31%. Since the significance level was set at 5%, it is thus lower than 31%. For this reason, no significant difference is assumed between the two samples, and they therefore come from the same population. The second way to determine whether or not there is a significant difference is to use the confidence interval of the difference. If the lower and upper limits runs through, there is no significant difference. If this is not the case, there is a significant difference. In this t-test example, the lower value is -6.328. And the upper value is 18.118. Since the lower and upper values are 0, there is no significant difference. It is common practice to first display the two samples in a chart before calculating a t-test for independent samples. For this purpose, a box plot is suitable, which visualizes the measurement of central tendency and measurement of variability of the two independent samples very well.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.